Hello guys, welcome back to the channel. Slightly different video today. This is not going to be a repair, it's going to be a modification. So this goes in my outside porch. This is nothing special, it's just cheap one from B&M. But there's a few things I want to do to it. So it's got a solar panel array which doesn't get used because there's no direct sunlight, so it doesn't charge up for starters, which isn't too much of a concern because I'm happy just to unhook it off the door and then take it in to charge up. Now there is no charging ports, so what I've been doing is taking it apart and then manually charging it up with a little charging board circuit. So what I want to do is graft on a charging circuit with a port sticking out externally. That's what I want to do for starters. Also there is two LEDs, one for obviously illuminating the exterior when it detects motion. So I want to cut away in here, I'll show you when we take it apart, and graft on some other LEDs. So we'll probably get another two each side LEDs to make it brighter, more illumination. And then here there's like a passive LED which is on all the time, which is draining the battery as well when this is on also. So I want to get rid of that so it cuts down on the drainage of the battery. And also I want to implement a bigger battery as well. So we look at the back of the rating label, we've got a 500 milliamp lithium ion cell, which is it's not a massive amount of capacity, but yeah, I just want to sort of do some modifications to it, have it outside for longer between charges and have it a little bit brighter, and also the ability to charge it up without taking it apart. So that's what we're going to do today.
Ideas are coming, things are happening here.
So this here is the sensor as well, so it's got a fractal lens to direct infrared in all directions. So this is a passive infrared sensor. So this detects not movement or motion, but infrared radiation. Now our bodies emit infrared radiation. We can't see it with the naked eye, but this can detect that, and that will send a signal to the board, and then the board interprets that as a switch state to turn on the light.
Wow.
So yeah, let's get it apart. Okay, here we have this, very simple inside. This is the cell that came with the device. It's was it a 14? Yeah, 14, turn it around. A 1450, 500 amp, a milliamp lithium ion cell. Again, it does the job, but what I want to do is graft on another battery in parallel. So the voltage stays the same, however, we'll increase the capacitance. Also, this is what I've done temporarily, is grafted on a little charging, lithium ion charging board circuit that just goes off to the battery, type C. So I want this going on, mounted somehow inside here and coming out the side, or the back perhaps. There's quite a lot of real estate in here, so there's a lot of room to play around with. And then we have the board here for the light coming out of the device, which I want to modify as well. What should we tackle first then, eh? Light, battery or board? Let's do a battery first. I've got lots of odds and sods. I'll also show you my first little external floodlight from Temu.
China.
Absolute garbage. Absolute garbage. What I liked about this though, when I bought it, was the fact that you can orientate this anywhere you want. However, it's just held in place with an interference fit. Now, subsequently, when you shut and open the door, it works loose and it drops out. But I will say though, lots of LEDs, very bright. So that's what I liked about it. This has got one LED. This has got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah. No, it's got 9. I can't count. Jesus Christ. It's got 9 LEDs.
You're not just wrong, you're stupid.
So yeah, what I want to do is use this as a parts device. Take these off, so take 2 of them off and put into here onto the existing board. So that's that one. But yeah, this is crap. This is, and it uses AAA batteries, so it's not even rechargeable either. So here's some odds and sods we've got. Might use this as a connector going outside of the device. So we can nick this little like daughter board just for connecting up the external charger. We can nick that. Got a battery here, so this is quite bigger, English.
You know I don't speak Spanish. In English, please.
It's got a lot more capacity, so that's 1800 milliamp hours. Running is 500, so we put them together, we've got 2300 milliamp hours.
You're incredible at math.
4 times, so that's going to be a big improvement there. So what I'm thinking is we can bypass this connector, put on the positive and negative of the wires from this board, have this sitting somewhere. We've got 2 through holes that we could put some screws through and then tap into the plastic with some just self-tapping screws. Have that in place and yeah, wire up the positive and negative to this board, have this board tucked away somewhere and then off to the battery. So yeah, that should be pretty simple to implement. Right, let's desolder these wires quickly. So I'm going to have to extend them, far too short. So something else we need to do. It's got this Captain tape on here that we can peel off. I'm going to put a smaller tip on so I don't short anything. And that's probably a better idea, isn't it? Let's get this on there, a little bit smaller. Solder on this mat. This plate, sorry. Just tin the wires. Let's put the fan back on. That's them tin. Let's get these wires removed. Alright, that's them off. Set them aside. That one on. Just a bit of solder on the tip a little bit. It's time for the positive. Ignore the colour, it is a positive. Alright, that's that one on. Let's turn that off, let's turn that off. So this, some new Captain tape on there to try and insulate those conductors and pads. I don't want them touching anything. So Captain tape. Because the negative wire is shorter, we'll have this orientated closer to the negative terminal, which is here. Get this unscrewed. Right, that clipped out of the way. Where'd the other screw go? I took it out and oh, it's in there, look. Hiding away. Right, you go there. I'm very disorganised right now. It's Saturday morning. Let's have a drink, let's get hydrated. Right, let's get some new wire soldered. It's got the battery charging leads here, and we've got the battery itself, and then we're also going to attach now this second battery. So let's trim these back. Again, there's no right or wrong way of doing this. This is just me, just tinkering, having a little play.
Kind of make it up as I go.
It's going to be Frankenstein now. Maybe even a bodge. You know, Frankenstein bodge right now. So just going to tin these wires as well quickly. Right, get some solder on you. Oh, fan. Try and stop me breathing in some lead.
Oh well, who wants to live forever?
So solder it's 60% tin, 4% lead. So there is lead in there, so that is nice and fun for me to breathe in. So let's put the fan on. Let's try and prolong my life as much as possible and not decrease it instead. Right. Let's get that out of the way. So I'm not going to glue it in just yet, I just want to get the wire soldered on first. It does sit quite snugly though, between this screw standoff and the casing for the battery. That's, yeah, a bit of hot metal glue in there and that'll be fine. Nice little interference fit. Right, where's my tweezers? Come here, cheap tweezers. My Chinese tweezers that bend with little effort.
He's just cheap.
Right, let's get you in there. It's be easy to have a screw terminal or something. Alright, that's the negative in place. Let's tuck that. Let's tuck this out of the way. He says. Right, that's out of the way. Now we want the positive. So that can go across there and then over here. We're going to have 4 times as much capacitance now. Right, that's a negative on now. Let's just double check this still works. So that's on. Yeah. Great stuff. That's the battery in place. Let's get some hot metal glue in there and get that secured in place. Let's turn this off. So I do have this Bosch glue pen, which is quite handy to have. It's wireless, or not wireless, cordless. All right, solid green light. We've heated up. Oh, that's not going there. Let's go away. All right, let's get some glue in here. Try and get some down here, or just at the top maybe, just keep it there. I think having that just at the top will be fine. It's just to hold it against that standoff. I'll try getting there. Let's get a bit underneath. A little bit awkward. There we go. Alright, there's some underneath there as well. That's fine, let's turn it off. Okay, that's one job done. Got another battery grafted, so we've got two in parallel, so the voltage stays the same, but the capacity is increased. So that's great. That's that done. Now, next job is to tackle this. So we need to have some wire soldered to this. I mean, this can sit anywhere. It can sit in there, for instance. This needs to be mounted to go out externally. So what have we got to play with here? Or we just glue it to the bottom here and have it coming out this side. That might be easier. I think let's get some longer wires on it as well. They're too short. Just need to pull that wire through the other side. What's this? Alright, that's that done. Oh, fan, Jesus Christ. Suffocate. This is too small to hold on to. Very annoying. Stay in place, please. Do soldering, he says. It'd be fun, he says. Come on, you bugger, get out. Yeah, I'm not really holding that very well, am I? Right, that's off. I'm not gonna have the wire going through it. I'm just gonna have the wire sitting on top. Let's just get a bit more solder on there. And ground is the one on the left. Is it worth putting some captain tape on this as well to protect it, insulate it? Probably not a bad idea, is it? So we need to cut out a slot there.
Yes, well, let's move along.
I've made the hole a lot bigger.
Brother, what's that?
So I allow the charge lead to go through this hole and into this pool. Yeah, I've cleaned it up with a needle file. I've got some needle files here, so I use these instead, just to go around and clean it up. So it's super glued down for the meantime, but what I'm going to do is get this epoxy here, Gorilla epoxy, and then put that, or douse it across the board to keep that in place. Because it's quite an interference fit, plugging the lead into this port here, it's quite a tight fit. So if I just use super glue or hot melt glue, it's probably going to ping off with subsequent use. So we can use this. Let's get this going. So it's obviously a two-part epoxy. Snap off that. Yeah, let's give this a go. Should harden in 30 minutes and then fully cure in a day. So we've got 5 minutes of mixing time allowed before it starts setting. I think that's mixed quite well already. What I don't want is this thing going onto my lovely mat of Master Chief and his comrades. Right. I'm just gonna let that hang. Let's get that wire out of the way. Let's get that drip all onto that board. I've got no sort of. There's no applicator I've got to just get that all in there. I've got the port in place, that's going to cure. Done the battery. Let's now get this in place. This could just be set with hot melt glue because it's not going to not going to go anywhere. Nothing's going to be pushing into it to charge it up. It's just going to sit there. Right, let's make sure that's actually working, this circuit. It's worked before. Plug this in gently, because I don't want to disturb the epoxy that's still sitting. So we're drawing nearly 1 amp, so just shy of 1 amp. So that's charging both these batteries. Good stuff. Happy days. I could just take this connector off. I could just put the wires on there straight to the board if I wanted to. That's better. Let's turn this on. But yeah, I know you're watching this thinking this is a bodge. It is. This is not good on the eye. It's just there for function at the end of the day. So.
Not that there's anything wrong with that!
Join me for this ride of bodging. Of how not to bodge. Alright, this is just going to get smothered in hot melt glue now. What I'm going to do is desolder these wires so we have this board onto here to mount up. So I'm going to grind, because if you can see these are the tracers, so negative, positive, and I'm going to grind down on this side hopefully, and till we get to the traces, and then we're going to tin the pads and then get a new LED on each side, hopefully. We also need to remove this one as well, so I'm going to get some hot air in that, I think, and just take that one out in situ. Of course, if you can't see much, I'm just going to do this without the microscope. There we go, that's off. Question is, does this still function with that LED removed? Right. Oh, what am I doing? Of course it's going to be no light. This is not even attached. I'm trying to test it and this is not even attached. Can I just hold it on there? Just for the quick testy test. Huzzah! Alright, so it works still with the LED removed. Great, that's what we wanted. So this is now in place now. So again, all that's left to do now is get some more LEDs onto here. So we've got new battery in place, well it's not new but grafted in there, so in parallel with this battery. So now we're going to have a total of 2,300 milliamp hours opposed to just 500, so the actual device is going to last a lot longer between charges. We've got a little daughter board here with the micro USB to plug into with our external charging lead, and that goes off to our lithium ion charging PCB, which is then connected to the battery terminals. So that's all done. This is epoxied in. It's getting hard, so that will be that'll be fine. Taking the lead in and out. Some super glue on the base of this within hot melt. So again, this is not going to move. Batteries got hot melt. That's not going to move. Plus, it's got interference fit as well in a little recess, little slot here. So that's all good. I appreciate it doesn't look pretty. I will admit it's not pretty at all, but when the covers are on, no one's going to see it. But yeah, let's get this under the microscope and do some grinding. Right, so I've got some double-sided tape on there, foam tape, just to hold it in place because my magnets are not going to hold it in place. This is too small on the board. So let's get the grinding pen out, which I bought this for. This is the exact job I bought it for doing traces, trace repairs. If I get in. Right, let's change this tip. That's not going to do it. Is this too big? We'll give that a go. We're starting a slow setting, but I believe there's a trace from there to there, so we're just going to go across. Maybe a bit quicker. I think that is too big, actually. Get a smaller one on there. Bit more precision. Bit more precision. Alright, here we go. Look at that. See some copper. That one side. Let's clean that up, see what that looks like. Get some RPA on there, get a little brush, clean it off, and see what we get. Brush that off. I think we can work with that. Let's test with the multimeter for continuity. So this rail here should be positive, which it is. Let's make sure it's not shorting anywhere. Nope. And this rail should be negative, which it is. Happy days. So what we can do is test LED as well. So negative onto that rail, positive onto here. Okay, you can't see it because my multimeter is not that powerful, but if you notice here, if I turn the brightness down on the microscope, you'll probably see it actually. Just do that. Right, you ready? Okay, so we've not disturbed the circuit at all, apart from revealing the desolder mask. Not disturbed it at all, so that works. Great. Let's see if we can get some LEDs across there. We'll tin this rail, get some solder on there. Now we need those LEDs. Similar width. Might have to draw some solder onto it, or we can go down a bit with the Dremel maybe. Right, let's get these off. I don't know how easy they are to take off because it's plastic without damaging them. So let's just try one first. We'll set the hot air low. We'll do 200. That might be hot, might be too hot, but we'll give it a go first, and then so let's turn the torch down and let's see if these LEDs still work. Alright. Not sure which side's positive. I'm guessing this little indent here denotes the position for positive or the polarity. I could look it up, but we'll just use the multimeter. We'll do it on the ones that are on the board, see which way around it is. So again, multimeter in continuity, diode mode. So let's do this one. So that indent is there, so positive, negative. So it must be the other way around, negative must be that way around then. Okay, yeah. So this is the negative side with that little cutout. Alright, let's test the ones that we took off. We focused the microscope. So we've got the negative here, the positive this side. Oh, okay, that one works. Okay, that one works as well. Right, okay, they work. Okay, so we've not damaged them just yet, but we still need to get them on the board. Alright, let's see if that works before we do anything more. Let's turn it off. So the ground is that side, isn't it? Aha, let's turn the brightness down, you'll see that. Right, so negative, positive. Right, so that's on there. So it'll be brighter when the battery's connected. Okay, that's good. That's that one done. We should have all three lighting up now. Fingers crossed. Alright, so positive, negative. Ah, there we go. Alright, that's done. So if we get this off, peel that off. Right, let me have a tidy up because I'm literally doing my head in now. There's too much mess, way too much mess. Right, let's get this all out of the way. Wait a minute. Oh, that's off. That's off. So this will be on. Hey, that's nice and bright. That is. Happy days. Right. There's just one more thing left to do. Is we're gonna have to make a little cutout onto this reflector to accommodate the two other LEDs. Right, so that's now the whole cutout to accommodate the three LEDs. The pads are on the inside for the wires, so I'm going to have to solder them on first and then we'll get this in place. So let's do that now. Right, that's that done. So go off and then on. So they're all working still. Great stuff. Let's get this back in. Put this back together and charge it up, and we'll get it on the back of the door and we'll test it there. So just a little update, the charging light on the board has gone blue, indicating that we have full voltage or max voltage on the battery, which is good. So let's get to the door and yeah, see what it looks like. How much battery life? 4 times as much battery life. Really struggling to speak right now, honestly. Oh my days, I'm having such difficulty here. Right. Just don't try saying. Don't cover what I'm doing. I'm just being absolute moron here, lazy. Oh, I've just nipped the battery one off by accident. What a melon. Get that into the sides. So we'll have the shortest side, shortest lead facing the negative, or the negative